For most of the artificial intelligence boom, the leading models came from a small group of American companies. OpenAI, Anthropic, Google, and Meta controlled the systems that developers used to build chatbots, coding tools, research assistants, and autonomous agents. Chinese companies were often described as followers, restricted by limited access to the world's most advanced chips. Now a model called Kimi K3 is challenging that story. Kimi K3 was created by Beijing-based Moonshot AI. It contains approximately 2.8 trillion parameters, making it one of the largest open-weight models ever announced. It is designed for advanced reasoning, long coding tasks, professional knowledge work, and AI agents that can complete projects across many steps. But its enormous size is not the most important part of the story. The real threat to American AI companies is that businesses can download Kimi K3, modify it, run it on their own infrastructure, and potentially pay far less than they would for a closed American model. The AI race is no longer only about which system scores highest on a benchmark. It is becoming a battle over who can make advanced intelligence affordable enough to use everywhere. That shift is already becoming visible in the United States. American developers and technology executives are experimenting with Chinese models including Kimi, DeepSeek, Alibaba's Qwen family, and models from Zhipu AI. In many cases, they do not claim that the Chinese systems are always the most capable. They use them because the performance is good enough and the price difference is difficult to ignore. For a person asking a few questions each day, the cost of an AI model may seem unimportant. For a company processing millions of requests, it can determine whether an entire product is profitable. Imagine a software business using AI to inspect documents, generate reports, write code, and respond to customers. Every request consumes tokens, the small units of text that AI models process and produce. A minor difference in the price of one request becomes a major expense when repeated millions of times. This creates an opportunity for companies such as Moonshot. Kimi K3 offers a 1 million token context window, according to Moonshot. In theory, that allows the model to process extremely large collections of information in a single session, including long software repositories, multiple books, company documents, or extensive research material. It also uses a mixture of experts architecture. A conventional model may activate much of its network whenever it processes a token. A mixture of experts system contains many specialized sections but activates only a small selection for each task. Kimi K3 reportedly contains 896 experts while using only 16 for each token. This allows the total model to become enormous without requiring every parameter to operate at the same time. The design can provide greater capacity while controlling the amount of computation required for each response. However, 2.8 trillion parameters do not automatically make Kimi K3 better than every smaller model. Parameter counts are difficult to compare across different architectures. Training data, software optimization, reasoning techniques, and the quality of post-training can matter more than raw size. Independent testing will be essential. Moonshot says the model performs strongly in coding, reasoning, and agentic tasks. Early evaluations suggest that it competes with several frontier systems, although the most advanced American models may still lead across a broader range of abilities. That may still be enough to disrupt the market. A cheaper model does not need to become number one at everything. It only needs to solve a company's specific problem reliably. A business summarizing invoices does not necessarily need the best model ever created. A developer generating routine code may accept slightly lower benchmark performance in exchange for dramatically lower operating costs. This is similar to what happened in other technology industries. The most technically advanced product does not always dominate. Affordable alternatives often spread faster because more businesses can use them. Once adoption grows, developers improve the software, companies build new services around it, and the product becomes harder to displace. Open weights accelerate that process. A closed model runs on infrastructure controlled by its provider. Customers interact with it through an application programming interface and must accept the provider's pricing, policies, and service availability. An open-weight model gives users access to the model's learned numerical parameters. They can host it on their own servers, fine-tune it for specialized tasks, change parts of its behavior, or deploy it in environments where sensitive data cannot leave the organization. This can be attractive to hospitals, banks, governments, manufacturers, and defense organizations that may not want confidential information sent to an external AI service. It also complicates the usual security debates surrounding Chinese technology. Using a Chinese-hosted cloud service could expose information to legal, political, or surveillance risks. But an open-weight model can be downloaded and operated inside an American or European data center. The organization running the model may control the servers, network, logs, and data. In that situation, the country where the model was originally developed may matter less than the infrastructure where it is deployed. Open weights do not eliminate every risk. The model could contain hidden behavior, vulnerabilities, bias training data, or capabilities that are difficult to detect. Companies must inspect the software, test the outputs, secure the deployment, and control which tools the model can access. But these are also risks found in models developed outside China. The rise of Kimi K3 is therefore creating an uncomfortable policy problem for the United States. Washington has spent years restricting China's access to advanced AI chips. The goal was to slow the development of systems that could strengthen China's economy, surveillance capabilities, military technology, and cyber operations. Those restrictions may have increased pressure on Chinese laboratories to become more efficient. When unlimited access to the most advanced hardware is impossible, researchers must find ways to train and operate models using fewer resources. That encourages improvements in model architecture, memory management, inference systems, and software optimization. DeepSeek demonstrated how powerful that strategy could become. Kimi K3 now extends the challenge with greater scale, long context capabilities, and an open-weight release strategy designed to attract developers internationally. The result is ironic. The United States attempted to limit China's AI progress by controlling hardware. Chinese companies responded by building models that may be cheaper, more open, and easier for the rest of the world to adopt. This does not mean export controls have failed completely. Advanced chips remain critical. Training and running a model as large as Kimi K3 still requires enormous computing resources. Moonshot reportedly had to pause some new subscriptions after demand strained its available capacity. That bottleneck shows the difference between publishing a powerful model and operating it for millions of users. American companies still have major advantages. They control much of the world's advanced chip design, cloud infrastructure, AI research talent, and enterprise software market. OpenAI, Anthropic, Google, and Meta also continue to release more capable systems. But their business models may come under pressure. If open Chinese models become nearly as capable while costing much less, American providers may need to reduce prices, offer greater customization, or release more open technology. The competitive advantage may shift away from owning the strongest model and toward providing the most reliable infrastructure, tools, security, and customer support. This could also benefit NVIDIA and other chip suppliers. An open model can be downloaded by thousands of organizations, but those organizations still need hardware to run it. As more businesses operate models locally, demand for accelerators, memory, servers, and networking equipment could increase. The model creators may compete on price, while the companies selling computing infrastructure benefit from the expansion of the entire market. There is also a geopolitical dimension. China is presenting open AI as a tool for countries that cannot afford expensive American systems. Governments, universities, and startups across Asia, Africa, Latin America, and the Middle East may find open Chinese models more accessible. They can host the systems locally, adapt them to regional languages, and build domestic services without paying continuously for access to an American platform. That gives China influence without requiring every user to depend directly on a Chinese cloud provider. The model itself becomes a form of technological infrastructure. The United States could attempt to restrict Chinese AI models, especially in government systems or sensitive industries. But a complete ban would be difficult to enforce once model weights have been downloaded and copied across international servers. Unlike a physical chip, software can spread instantly. One file can be duplicated thousands of times, modified, renamed, and integrated into other products. A ban might slow official adoption, but it could also push use into less visible environments. It could protect American companies from competition while reducing the ability of researchers to study Chinese systems openly. The more practical response may be competition rather than prohibition. American companies could build cheaper models, release more open weights, improve transparency, and make local deployment easier. Governments could establish security testing requirements that apply to all advanced models, regardless of where they were created. The rise of Kimi K3 does not mean China has already won the AI race. The model's strongest performance claims still require broad independent verification. Moonshot must prove it can support real customers, maintain reliable infrastructure, and fund the enormous cost of continued development. Open models also face a difficult business problem. Releasing weights can increase adoption, but it may reduce the company's ability to charge customers. Moonshot must convert developer interest into sustainable revenue while competing against some of the richest technology companies in history. Still, Kimi K3 represents a major change. The first phase of generative AI was defined by surprise. Models suddenly learned to write code, create images, and hold natural conversations. The next phase may be defined by abundance. Advanced intelligence will become cheaper, more customizable, and available from a growing number of countries. Companies will no longer ask only which model is smartest. They will ask which model is affordable, controllable, secure, and good enough for the job. That is the competition Kimi K3 is forcing into the open. China may not need to build a model that defeats every American system on every benchmark. It may only need to offer powerful intelligence at a price the world cannot ignore.